Hi, Professor Amal. Thank you so much for joining us at Women's Health AI. Can you give us a brief overview of your background and your current research focus? I know that you've really been involved on both the academia and the industry side.
Hi, Disha. Thank you for inviting me. Just to start about background about myself. So I'm a research professor at Northeastern University, and I have an appointment in the bioengineering department at the College of Engineering. I'm also a member at the Rue Institute in Portland, Maine, and at the Institute of Experiential AI. I'm a visiting professor also at Harvard University, Harvard School of Medicine in the Transplantation Research Center at Brigham and Women's Hospital. So about what we do in the Amal Lab for precision medicine, so we focus on developing innovative deep learning and like AI models for multimodal data, aiming to improve disease care. We focus on two main diseases where we focus on cancer and cardiovascular disease. And when we say developing deep learning models for multimodal data and multimodal medical data, that includes electronic health records, where we can find doctor's notes and lab events, vital signs. And we also work with imaging, medical imaging data like MRI, CT scans, and mainly with histopathology scanned images. And the third modality is omics data, where we look at transcriptomics, genomics, proteomics, epigenomics, and the reason that we focus on this multimodal data is that we need to provide comprehensive overview about the patient. So what we mainly focus on in terms of tasks that we are trying to address. So we focus on early prediction of disease. That means we are trying to predict a year ahead of the disease, so we can be able to intervene and prevent the disease if possible. And the second task is trying to, when the patient has the disease already, we try to predict or diagnose the patient in a highly accurate way and timely way. And the third task is prediction of adverse events. So for every disease, there are that can cause complications and adverse events. It can be in peripheral artery disease, as example, it could be death, it could be limb loss, like amputation. In some other cardiothoracic disease, it could be multi-organ dysfunction, prolonged ventilation, and so many other complications. And the fourth task is to recommend personalized treatments for patients, and specifically in cancer, as we know that there's no one treatment that fits all, and every patient would respond different to different treatments. So it's important that based on the comprehensive overview that we have about the patients, to try and basically recommend the optimal and personalized treatment.
And I think specifically talking about that first one you mentioned with the early diagnosis, I know you've done some incredible work using machine learning for breast cancer diagnosis. And I was reading about it and I saw like 99.7% accuracy, which just sounds incredible. So could you share a little bit more about what that tool was?
Yeah, so for breast cancer, we developed innovative ensemble deep learning models that were able to diagnose both, predicting both the subtype of the cancer and the severity of the cancer in near perfect prediction. And also, when you say 99.7, it's kind of raised some questions, but we evaluated these results on different data set, which is the challenging. Usually you treat your models, you train your models on one data set, and then you evaluate this on the same data set. So what we did is we evaluated that on external data, and that makes our results extremely reliable. And so when we say ensemble deep learning, what we did is we developed deep learning models that can understand and perform fusion of multiple models that are expert in image processing. Each of these models is expert in one domain of image classification and image processing. And then based on the decision of each of these models, we make the accurate decision. And it could be like the analogy is like when you have, let's say, a biopsy that we work with, breast cancer biopsy, you send it to a pathologist. So the pathologist, it would take like 2 or 3 weeks to get the answer for this biopsy. And then they need another opinion. So for another pathologist and another pathologist, it takes so long. And also, so what we did is you can look at this ensemble deep learning models as multiple pathologists that each one of them is expert in one thing or in a couple of things. And then the decision is made on all of those. So each one of these models were trained on data sets that looked on that was trained on data that was labeled by different pathologists and different centers. So it could be accurate also on diverse and external data sets.
And then I'm just curious, you mentioned using an ensemble model with different models specifically trained on different data sets. Were those all weighted the same? How did you decide which model to prioritize? Was it based on their accuracy or?
Yeah, so we usually, there are multiple techniques that we use. We use voting as example. Mm-hmm. And then depending on the similarity basically of the image and to which model was trained on similar data, that way we can give higher weight to these models. And this way we can be able to basically dispatch or like give more attention to the model that has more similar of this type of tissue.
Okay, that's amazing. And this was all with histopathology biopsy data?
Yes, it's histopathology biopsy data and on diverse data set.
That's awesome. And then now kind of moving a little bit more general to your thoughts on this field. In your opinion, what would you say the biggest gap in breast cancer care that exists today and how AI can help address it? And then if there are any challenges that you see standing in the way, maybe you could provide some color on that.
Yeah, so as we know, the final decision on the level, the severity of the cancer, but in breast cancer and on all cancers is decided by the pathology. So the pathology is basically the modality that is decide the ground truth, like based on how the pathologist would decide would diagnose it. So for in that case, there are many challenges in this area. One of the challenges is the shortage in breast pathology specialists, specifically, and in general, the shortage in pathologists in general, like for all cancers. And the additional challenge is the increasing amount of biopsies that are being taken recently, because of the awareness, to cancer screening. So more and more people are taking biopsies. So there is increasing amount of biopsies. And an additional challenge is the inter-observer variability. So if there is underestimation of the severity of the cancer, the patient might get under treatment. And if there's, and the other way is to have over treatment, which would affect significantly the patient. So, and in this case, this is where like AI can help in an efficient way. So if you take the pathology process where the pathologist would take the biopsy and look for patterns, it might take them hours to try and find these patterns and make the diagnosis. So we're talking about hours of the diagnosis time, but until we find a pathologist, because of the shortage in pathologists and this increasing amount of biopsies, it might take a couple of weeks or maybe 3-4 weeks even to get the results. And in some cancers, it can be very critical. Every week is very critical. So when we utilize these highly accurate, specifically the models that we developed in breast cancer, the diagnosis can happen in seconds. So that could be extremely important for the efficiency of these of the treatment. And as we said, that because of this inter-observer variability, when our models are trained on multiple multiple decisions of multiple pathologists, this model is basically as wise as so many pathologists.
That's
Yeah.
No, go ahead.
Yeah. So what I'm saying is that we are taking these models are able to make the work of multiple pathologists, and we said that we need to find a pathologist in a couple of weeks. Let's talk about like when we need another opinion or 2 or 3 opinions. So that would take so long.
Absolutely. And then I'm just curious. I've done a lot of research in ultrasounds because in a lot of places there isn't a lot of access to biopsies. So I was wondering if you think ultrasounds have potential, if you apply deep learning to potentially help with the diagnosis process. Do you have any thoughts on that?
Yeah. So as I mentioned in the beginning, in my lab we focus on multimodal data.
Mm-hmm.
And the reason for that is that we want to provide a comprehensive overview. So it's right that the biopsy gives the the ground truth, or like the most accurate diagnosis. But we would like also to look at other modalities, including electronic health records, including ultrasound, including CT scans. And we have a company, a spin-out that was established. It's called Santovia Path AI, that commercialized the patents that I developed and that we developed in the Amal Lab. And one of the focus of this funding that we received from this company, from the spin-out company, is on focusing on multimodal data. So we would like to look at pathology together with electronic health records and other modalities like ultrasound or any other modalities that are available as omics data. So in order to provide this comprehensive and overview, and also because we want to provide explainable AI. It's explainable AI has been like at the research now, and it's getting a lot of attention. And by having these genetics or omics data and electronic health records and some biomarkers that we found in ultrasound or in CT scans, this would give more confidence to the decision, the clinical doctors, to have more trust and more confidence in our decision, in the AI decision, basically.
Mm-hmm. And then kind of going even more broad, in your opinion, are there any underexplored areas in AI-driven medicine that aren't receiving enough attention right now?
Yeah, so in terms of like AI-driven medicine, or the whole domain of AI and precision medicine, only recently it has been, although there are research that have been done a while ago, but the main important thing here is how do we translate this research into the clinic? And this area is like under developed and not getting enough attention. It's starting to get attention, and this is what we are focusing on in my lab, to also in this spin-out company of Santovia Path AI. So this domain is still not getting enough attention, and specifically the areas that are under addressed like less getting less attention is the multimodal data. So if you look at research, every research is focusing on MRI as example to diagnose, or histopathology, or looking at electronic health records. So when we and the area of developing models that can be expert and can understand this complex interrelationship between these different modalities is not giving enough attention, being given enough attention, and this is what we focus on. Specifically now, we have developed models that are expert in each one of these modalities, and now we are collaborating with pathology companies and other companies that and hospitals, of course, that can provide us with these multiple modalities. So getting these multiple modalities per patient is a challenge. And also AI applications in treatment response prediction. As we talked in the beginning, we can't give all patients same treatment in same order, because every patient would respond differently. So prediction of the response of the patient is also not given enough attention in these days, and these are the things that we're working on.
Yeah, and actually, you just answered this question, but I'm so fascinated. I've thought a lot and explored a lot of ways to integrate multimodal data, but I always struggled with having publicly available data that has all of these different modalities. So how do you go about getting all of these things like electronic health records, imaging, all of that?
Yeah, so couple of years ago, even before this area got attention, I published a paper about how do we fuse these information. First of all, like how, even if we have this information, we need a way that can wisely integrate and fuse this information. Because if you give the model one model imaging and the other model text, this architecture of like AI architecture, advanced AI architecture, needs to understand how to deal with all these different modalities. So in terms of acquiring this data, that's the reason why we, for each one of these multimodal projects, we need to collaborate with organizations that have this data. As example, we're collaborating now with a pathology company organization that has the relationship already with the hospitals.
Oh.
So we're talking to the hospital, to the pathology. So from the hospital, we can get the electronic health records, we can get the previous MRI or X-ray, ultrasound scans that were done, together with the ground truth of the pathology. Okay. So this is one of the big challenges, by the way. Acquiring this data and this multimodal data is one of the biggest challenges, because you don't find it publicly available. Like you can find, we worked on in breast cancer, we found large-scale data set only for histopathology, or you can another data set that is only for MRI or CT scans. So this is one of the challenges, basically.
Yeah, actually, that's exactly what I was encountering, because they were just specialized. And then clinical adoption, so much work is being done in this space, but clinical adoption of AI-powered diagnostics in almost any field is still kind of slow. So what do you think is the biggest roadblock? Is it just distrust, or is there something else?
Yeah, so one of the main things is the ethical and regulatory concerns regarding AI decisions that are driven by AI or that are made by AI. So the ethical is very important, and there is also some research that is related to ethical AI today. And the regulatory the regulatory aspect is a big challenge. And another thing is as you mentioned, the trust of the clinical team. And for that reason, as example, we We are running always studies with pathologists and with oncologists that are using our tool. We developed a web tool that can make the diagnosis, and we always run studies with pathologists and the clinical team to see what would make them have more trust. Like one of the things that I mentioned is explainability. So if we are diagnosing breast cancer biopsy, then we also provide segmentation of the areas, like markup of the areas that caused this decision. This would cause more trust by the clinical decision making. When we look at the electronic health records, also the additional modality, we can provide some also biomarkers from the history of the patient. And also if we look at the omics, so we look at these biomarkers that are related to the genetics and on the genomics data, like the transcriptomics data. So this can provide more trust, but the trust is definitely one of the roadblocks. And then the acquiring this data, and also, the process of getting access to this data. So there are processes of like internal review board, data use agreement, and how are we going to use the data. So all those are making this process complex and taking time. But we're working on that, and we have good collaborations that are ready and would like to be part of this translational process.
Awesome. Yeah, I think there's such a big push for transparency right now and moving away from the black box, just diagnoses. So do you envision a future where AI diagnostic tools can operate with minimal human oversight, or do you think that incorporating experts during the process is always going to be really important?
Yeah, so I see that the AI will be part of the clinical team. So the AI will make the decision, and then based on the confidence, these diagnoses, like the patients would be prioritized in terms of like the more severe would require, the more severe with less confidence would be seen by a doctor, like diagnosed by the specialist. But in many cases where we, as example, in our model for breast cancer, we develop near perfect algorithm. And then even like in human diagnosis, there is 5% error. And also specifically in pathology, so the same pathologist, like different pathologists can make different diagnosis for the same tissue. And from my conversations with pathologists, even if you give the same pathologist in couple of months the same biopsy, they might diagnose different. So AI here can help significantly. And so I see that in some areas, AI will be there very soon and will be able to perform work of the clinicians used to do. And in some areas, it will take some time. So yeah, this is where I see the AI in the clinic today.
Mm-hmm. And then if you had to bet on one breakthrough that will transform cancer care in the next decade, what would you bet on?
Yeah, so integrating the AI and genomics is one of the things that would be one of the breakthroughs, specifically given the fact that today we don't have that much access to genomics data, together with these biopsies and other modalities that are more accessible to researchers that are conducting research in AI. So this area can be very important. And then the whole area of personalized treatment recommendations is going to have breakthroughs, because today we're not there yet. Like we can predict the treatment, try and predict the treatment, but the sequences of treatments that are personalized to the patient is still, I think that still underexplored and would have a big breakthroughs. And as we said, this, since pathology is the ground truth, is the thing that would the modality that would make the final decision. So I see the biggest breakthrough would be in digital pathology and AI, and this is the Santovia Path AI startup that we established in order to be able to redefine pathology. So if you remember, 2 decades ago, we had radiology, right? And radiologist needs to see the images. Today, you can send the image to radiology all over the world. It's not there in pathology because most of the hospitals are not scanning their pathologists. So they need to send the slide itself to some areas. And this is going to be the biggest breakthrough in cancer research area.
That's awesome. And then I know your lab focuses on cardiovascular and pathology for cancer care. Do you also look at this personalized treatment aspect?
Yes. So, as example, in cardiovascular disease, we look at now we have published a couple of papers that are looking at treatments. Like, let's say if a patient has PAD, peripheral artery disease, so the sequence of treatment and which treatment is being given first would affect the patient lifestyle and adverse events. So we have run studies that are related to analyzing these pathways, and with advanced visualization techniques that can help in this decision making during, depending on where is the patient at what point of the treatment. And also we have developed we sent a paper to JAMA Cardiology that is related to predicting sequences of treatments and early detection of these adverse events for cardiovascular disease. In cancer, we are starting to collaborate with Dana Farber also on breast cancer, where we want to look at the tissue before the treatment, after the treatment, and half year after the treatment. So these types of research are very rare because you need to get this data. So you need the clinics that has this, taking these biopsies, and then the transcriptomics can be taken, so we can make sure to predict the most accurate and optimal personalized treatment also in breast cancer.
Mm-hmm. And so just as a last question, for students and early career researchers who are really interested in exploring AI-driven healthcare, given all your experience and everything you've done in this field, what would you recommend is really the best way to get started?
Yeah, so in this case, what I always recommend also to my students is that they need to aim for developing a strong foundation in AI and also in the medical data analysis. So you need to be able to get proficiency in the healthcare domain or the disease that you're going to work on, and also strong foundational AI techniques. And then one of the most important things that we also like, today you can't find a lab that is working only on one discipline. So I recommend students to explore interdisciplinary areas where, as example, when we take AI and medicine, this is like interdisciplinary area. So these projects are very important and would provide them a system understanding rather than just focusing on one thing and understanding one thing. It will make them understand what are the implications of the advancements in AI in medicine or in other domains. And the last thing would be to participate in online courses, or like at the university, if they're in the university, or hackathons and to search for mentorship opportunities. So always to search for opportunities if they're in the university, then to search for professors that are dealing with this, that are conducting research in the area that they're interested in, and ask for mentorship and participating in these labs.
Absolutely. Well, thank you so much for speaking to me today and kind of giving me some color on your background and your thoughts on this field. Just thank you so much for your time.
Yeah, thank you for having me.